Hi folks, today's lesson in the CompTIA Network Plus course is binary. More specifically, binary math or binary conversion as some call it. Now this along with subnetting is something pretty much anyone in IT needs to know, and it's also something everyone will use somewhere in their IT career sooner or later. So before we jump into the technical stuff, just a little promotion. Do me a favor and boink that like button. And if you want to know when I release more lessons, also maybe hit that subscribe button. Okay, so now that we have that blah blah out of the way, let's get to the technical stuff, starting first with something called bits. So, if you're scratching your head at this point and squinting your eyes at the screen, wondering why I'm talking about bits, when you clicked on this video to hear about binary, well, hold on, we're getting to that. So, to understand binary, you need to understand what bits are first. So, first things first, what are bits? Well, bits is usually either a 0 or a 1. Zeros are usually seen as off, and ones are usually seen as on. You might also find the odd person that sometimes refers to this as 0 being as cold and 1 being as hot. So 0 sometimes is called cold and 1 is sometimes called hot. Now, some other interesting things you should know is that 8 bits is actually a byte. And at the same time, 8 bits is also an octet. So if anyone is wondering what the heck an octet is, well, if you've ever seen an IP address, you might have noticed that an IP address consists of 4 numbers, separated by dots. The same thing goes for subnet masks too, mind you. So the subnet mask goes hand in hand with an IP address, and often they're configured in pretty much the same place, at least when it comes to computers anyway. Okay, so what I'm going to do now is I'm going to add an IP address here on the screen for you folks. Let's put it there. If you look at the IP address there, you'll see there are 4 numbers and they are separated by dots, which I just mentioned. Each of those numbers you see there in that IP address is, well, actually an octet. So with that in mind, we can now say that an IP address actually in fact consists of 4 octets because we can see there's 4 numbers separated by dots. We also know based on what we said earlier that each octet consists of 8 bits, which are obviously ones and zeros. So if we have 4 octets consisting of 8 bits each, how many bits does an IP address actually consist of then? So it's a simple math equation. You just take 8 and you multiply it by 4. So the answer to that question is obviously 32. In other words, 32 bits. A normal IP version 4 address consists of 32 bits. So that's 32 ones and zeros. Just for interest's sake, an IP version 6 address consists of 128 bits. But that's obviously a topic for a different video. Today's video is not about that. So just thought I'd mention that since we were on the topic of IP addresses and how many bits they actually consist of. Anyway, if anyone is going to write the CompTIA Network Plus Certification Exam, I highly encourage you to remember what I just said, because all of it is going to be an exam. You need to know how many bits is in an octet, which we know now is obviously 8. You need to know how many bits is in an IP version 4 address, and obviously also in an IP version 6 address. So for IP version 4, that will be 32 bits, and for IP version 6, that will be 128 bits. Memorize those numbers, know them, live them, breathe them. You need to know those off by heart for this exam. Otherwise, they might catch you with your pants down. Not something we want to encounter, right? Now, regarding the IP address on the screen and the long binary number you also see on the screen, that will be the long one of the ones and zeros, those are actually in fact one and the same. Not sure if anyone noticed that or knew that, but it's kind of a fun hidden surprise for everyone. So, surprise! So if you were to go and take that exact IP address we've got on the screen, and if you were to go and convert that to binary, it would look exactly like the binary number you see on the screen right now. So basically, I went and did it for you guys already. So you can see each number in that IP address or subnet mask in some cases will be converted into ones and zeros. If you're wondering how I converted it, well, there are actually many ways you can go about converting it from decimal to binary, and then also vice versa from binary to decimal. In the end of the day, it's all math, and as some of you might know, with math, there's always more than one way to get to your answer. If you folks, for example, go run a search on platforms like Google or YouTube, you'll probably encounter hundreds, if not thousands of ways to go and convert binary to decimal and decimal to binary. And for the most part, they actually all work. In the end, it's going to come down to personal and unique preference since we're all unique. So I would say in the end of the day, go and check as many as you can, and then you need to go and find what works for you. So what works for me is not necessarily going to work best for you. You're still going to get your answer, but it might not be your method of preference. So there's many ways. And the same thing's going to apply to subnetting. So when we eventually do a video on subnetting, it's also a lot of math, and there's many ways you can get to your answer. And once again, it's going to come down to finding a method that works best for you. So in case you're wondering, yes, I am going to show you guys how I got to my answer. At least, well, one of the ways anyway. Um, but there's no rule that says you need to use my method. There's not a question in the exam that's going to test you on a certain method of getting to the answer. They just want to see if you understand what binary is, what decimal is, if you understand how many bits is in an octet and an IP address, and if you can go and convert it in general. There's not a specific way you have to do it to be able to pass your 90+ exam. There's many ways to get your answer, exactly the same as math. At the end of the day, as long as you get to the right answer, you will be able to pass this exam. That's all that's important here. Now, the method I'm going to show you on how I got to my answer is not necessarily my method. I can't claim credit for that one. It's a method that I've seen in many manuals over the years, networking manuals, obviously. And these manuals are not necessarily CompTIA or Network Plus. These are manuals, networking wise, for other vendors as well. Cisco, Huawei, you name it. All of these manuals have various methods, and a lot of them have this method that I'm about to show you guys. So all I can say is go out there, go Google it, go YouTube it, after watching this video, of course, and go and find a method that works best for you. But after you've watched mine and you've got a fair understanding of what ones and zeros are, and you understand the theory behind it, and you've already seen my method, then you can go and basically compare mine with other ones you'll find out there on other YouTube videos possibly, and then you can find what works best for you. Maybe you find another one that works best for you. And I encourage you to go and do that. Find something that works best for you. Because this is not to just pass this exam. At the end of the day, you're going to use this for the rest of your IT career. So you need to go and find something early that's going to make your life easier. It doesn't help you know a method and you get irritated with it every time you have to go and use it for the rest of your career. Find something that's, what's the word I can use? Fun, if there's such a thing in IT. Not sure if there is, but see if you can find one that's fun for you to go and use or easy for you to go and use. If I have to tell you guys an honest story, I had a group of students once with subnetting. Well, it's still math. It's not IP address converting, but it's still math. And I showed them a very easy way of converting or to do subnetting. And everybody in the class understood that method. And funny enough, the most brilliant student in my class, the smartest one in the class, could not get it. He just couldn't for the life of me understand how I got to my answer, even though it was the easiest method and he's the smartest student in the class. And then I thought, okay, you know what? You stay behind in class and I'm going to show you another method. And for the fun of it, I showed him another method of getting to the answer, a way more advanced, way more complicated method. And funny enough, that he could understand. So that just shows you that everybody is unique and we all have our own way of thinking. So if my method doesn't make sense to you or it seems too complicated, by all means, I encourage you to go and look for other ones out there. I'm telling you now, there's many ways to do this. It's not just my method. There's probably like 100 ways to get to the answer, and the same applies to subnetting. All right, so now that we've got that mumbo jumbo out of the way, let's get to the next topic, being decimal and binary conversion, which is most likely what you're watching this video for in the first place. So we're going to do this both ways. We're going to convert from binary to decimal, and once we've got that under the belt, we'll convert from decimal back to binary. And we're going to use the exact same table. There's a table we're going to be using for this to do both of them. So I'm going to first of all start you guys off with an example. Let's start with this one. What is, and then I've got a number there in binary for you guys. So it is 0, 0, 0, 0, 0, 0, 1, 1, 1 in decimal. So what is that? So you would notice there is 8 ones and zeros. So that's in other words an octet. And it also happens to be a byte. So that is going to be a decimal number. What that number is, we don't know. So what I'm going to do here is, on this nice open space, I'm going to go and basically copycat that number. Let's just stretch it out. So there we have it, nice, big, and in green. And right above that 8 bits that we have there, I'm going to add our little table. That is what the table looks like. So the table always starts with the biggest number from the left being 128, followed by 64, 32, 16, 8, 4, 2, and 1. You'll notice it keeps dividing by 2. So that's the table. We're going to put it above that number, and that's the exact same table we're going to use to convert back from decimal back to binary. So what I want you guys to do here is look at that green binary number and start from the left. So it's very important whether this is a 0 or a 1. Remember, zeros is off, ones is on. So looking at the number way on the left, what is the first one? It is a 0. That means it's off. So 128 will not be pulled down below this line. If it was a 1, that would have been considered on, and I would have added that number being 128 below that line. Every time we find one of these that's a 1, in other words it's on, we would take that number, move it down the line, and we just keep adding up those numbers. If it's a 0, we simply just add a 0 below this line. So with the first number in this binary number being a 0, I'm not going to move the 128 down below the line. I'm just going to put a 0 there instead. Looking at the next binary number we have here, what is that? It's also a 0. In other words, it's also off. So what's going to happen to that 64? Nothing. It's just going to stay there. So instead, we're just going to move a 0 below the line. So that's 0 plus 0, which is still just 0. Looking at the third binary number there, it's still just a 0. So the 32 stays above the line. We're just going to go and add a 0 below the line. So it's just 0 plus 0 plus 0. And that's obviously just still, well, 0. Looking at the fourth binary number there, what is that? It's still a 0, so it's still going to be the same story. 16 is going to stay at the top. We're just going to add a fourth 0 below the line. Looking at the fifth number there, still just a 0. And yes, I chose this number like that on purpose. So we want to start it nice and slow. So the 8 is going to stay above the line. We're just going to add a 0 below the line. So whatever this decimal number is, so far, it's still just going to be 0, this decimal number. So now you'll notice here the last 3 binary numbers are all 3 1. So all 3 of them are turned on. So looking at the 6th number there first, that one, what is above it? It's a 4. And considering that that one is on, we are going to take that 4 and actually put it below the line instead of the usual 0. So now we've got 5 zeros plus 4. So far this decimal number is going to be 4 or something higher. Looking at the next decimal number, sorry, not decimal, binary number, the 7th one, that's also turned on. And what's above it? It's 2. So we're going to pull that 2 down because that one is actually on. So now we've got 4 plus 2 here at the bottom. We're ignoring the zeros, obviously. And then lastly, the 8th binary number is also turned on. Happens to just be 1 above it, but still, nonetheless, we're going to pull that number down below the line. So what do we have here? We've got 4 plus 2 plus 1 plus obviously all of those zeros. We're not going to even count those because it's just 0. So what is 4 plus 2 plus 1? That gives us 7. So we can honestly say now that that binary number that we originally had in purple, which we basically converted to green because we needed a space, that simply is 7 if we were to convert that to decimal. So I think let's give you guys another one just so we can see this once more. And I think once you've got that under the belt, it should make a lot more sense to you. So I'm going to give you guys another one here. And this one is, what is 10101010? And if you're wondering why it keeps being 1010, that's on purpose. I just felt like doing that just for the fun of it. So I don't know what that number is just yet. So it's just 101010. It's just random ones and zeros. So that could be any number. We can already see it's not going to be just 7. It's going to be something. It's not going to be 0. If all 8 those bits were 0, the answer would obviously be 0 in decimal. Now, if all 8 of those bits were 1, in other words, all 8 of them are turned on, you would have taken that table we had earlier and you would have added all of those numbers together. That 128 we saw, the 64, the 32, the 16, and so on and so forth. If you add all 8 those numbers together, it actually equals 255, 255. So if you turn them all on, the maximum number you can have is 255. It'll never be more than 255, but also never be less than 0, so it cannot go into the negative. Okay, so what is that binary number? So like before, I'm going to add it here at the bottom for you guys in big numbers, nice and green. And like before, let's add that table above that binary number. So starting from the left side here, is the first binary number on or off? Well, this time it's actually on. And if it's on, what do? We take that number in the table and we pull it down below the line. So if it wasn't off, we would have just added the 0 below the line. So we're going to add a 128 below the line. We're going to pull it down the line. What is the next binary number? It is a 0. So we're going to ignore that 64 above it and instead just put a 0 below the line. So far, the decimal number is going to be 128 plus 0. So in other words, just 128. Looking at the third binary number, that is a 1. So it's turned on. We're going to pull that 32 below the line because it's on. Looking at the fourth one, it is off, so we just ignore it. Looking at the fifth one, it's on. And what's above it? 8. So we're going to pull 8 below the line. Looking at the sixth one, it's just off, so we're going to ignore that one. Looking at the seventh number there, it's on. What's above it? A 2. We're going to pull the 2 below the line. And then lastly, looking at our 8th little binary number here, which is a 0, we're going to ignore it because, well, it's off. Going to pull a 0 below the line, and there we have it. Now we've got the equation. So it's 128 plus, well, 32 plus 8 plus 2. I'm ignoring the zeros because, well, 0 is going to make no difference. So 128 plus 32 gives us what? 160 plus 8, that's 168, plus 2 is 100 and what? It equals 170. And there we go. We just converted another binary number to decimal, which in this case is obviously that number of 170. So we did that twice now. I think let's try this the other way around. Let's give you guys a decimal number. So I think the decimal number we'll use for this example, totally random, sucking it out of my thumb, is what is 197 in binary? I don't want to make it too big, but I also don't want to make it too small. Otherwise, it's going to be too easy to work out. Then this whole exercise is not going to serve its purpose. So we are going to use that exact same table we did before. So what we're going to do this time around is I'm going to give you guys the table first. So previously I would normally give you guys a binary number and then we would just go and add the table above the binary number. This time around I'm going to give you guys the table first. And we are going to look at that very first number way on the left of that table, which in this case is the 128. So we're going to take that number way on the left and we are going to compare it to that number which we need to go and convert, which in this case is the 197. So looking at 128, does 128 go into 197? In other words, is it equal than or less than 197? If the answer is yes, then we're going to make a 1 below 128. In other words, it's turned on. If the answer was no, we would make a 0 below that. So now considering that it's a 1, because obviously 128 is less than or equal to 197, we're going to make a 1, and below this 1, we're going to add another number. So we're going to take the 128 and subtract it from that 197. What does that give us? 69. Okay, I didn't plan for that, but I can't say that number with a straight face. My apologies. All right, so now instead of comparing these numbers to the 197, we've got a new number we're going to use now, which is that 69 one on the left. Now looking at 64, the next number on that table, does 64 go into our new number being 69? In other words, is 64 equal than or less than 69? If it's equal than or less than, it'll be a 1. In other words, it's turned on. If it's not, and it's bigger, we are going to make it a 0. So in this case, 64 is indeed smaller than 69, so it's going to be a 1. It's going to be turned on. And since it's turned on, we're going to take that 64 and subtract it from our last new number being the 69. So 69 minus 64 gives us what? 5. Now if that was a 0 instead of a 1, we would not subtract, we'd just carry on of the number. And that's what's going to happen. So yeah, looking at our new number, which is now obviously the 5, I mean, that's a very small number, and I did that on purpose because we want to on purposely give you guys the example that's going to be as real life as possible. So we're going to take the third number in our table, which is the 32. Does 32 go into our new number, which is 5? In other words, is it equal than or less than 5? It's way bigger. It's like more than 4 times bigger than the 5. So that is going to definitely be a 0, not a 1. We're not going to carry out over any numbers this time. We're still going to use the same number, which is 5. Now looking at the fourth number on our table, which is 16. Is 16 equal than or less than 5? It's way bigger, so that's going to be a 0 once again. Looking at another one, 8. Same story. It's way bigger than 5, so it's going to be a 0. It's definitely not equal to 5. It's not less than 5. It's more than 5. It's going to be a 0. Looking at the third last number, which is that 4. Now we're getting somewhere. Looking at 4, is 4 equal than 5? Or is it less than 5? So in other words, does 4 go into 5? Yes, it does, finally. So instead of the usual 0, this time we're going to actually make a 1. And if it's a 1 like before, we're actually going to subtract that number now from the last new number. So we're going to take 4 and subtract it from our last new number, which was 5. So 5 minus 4 gives us what? 1. I'm going to leave that here at the bottom. And that will be our new number. So there's going to be very little that's going to fit into 1 now, obviously. So looking at our second last number on our table being 2, does 2 go into 1? So in other words, is it equal to 1 or less than 1? Definitely not. In fact, it's actually twice the size. So that's definitely going to be a 0. And we are still going to stay with that same new number being 1. Looking at the last number on our table here being the 1, does 1 go into 1? So in other words, is it equal to 1 or less than 1? In this case, it happens to be equal to 1. So this is going to be on. We're going to make it a 1. And what's left? Obviously 0. So at this point in time, once you've done all 8 bits, you can ignore those yellow numbers I've got at the bottom. That was just to get you to the bit value or the binary value of whatever that number is. So there we go. The green number is your official binary version or binary version of that number. And I'm just going to go and add it nice and clean for you guys here at the bottom in blue so you can see what the official result looks like. So that, folks, is how you convert a decimal number to binary. So we showed you guys how to convert binary to decimal. We just showed you how to convert decimal to binary using the exact same table. Unfortunately, I cannot take credit for this table. I really don't know who came up with this table because I've seen it in so many manuals. I've seen it used by so many authors out there. There's like a gazillion ways you can go and do this. But the table is pretty much one of the easiest ways and one of the most effective ways for you to convert vice versa. So if you can remember that table, it's going to make your life a dream. Alright folks, so I really hope you've learned something, and like usual I'm going to ask you to give the video a like if you did learn something. It does indicate that you've enjoyed the video or that you've liked it. And if you'd like to know when the next lesson for this course comes out or when I release any other content, because I'm normally busy with more than one course at any given time, hit that subscribe button, otherwise you might miss it. And then like usual at the end of this video, I just want to give a special thank you and shout out to the sponsors of this channel. I've got Patreon ones, I've got PayPal ones, we've gained some, we've lost some along the way. Nonetheless, thank you very much for the current supporters. I really appreciate that. If you guys would also like to sponsor the channel so I can continue making free content like that, or like this, you can find that information in the video description down below. Alright folks, stay frosty. I will see you on the next lesson.